Hey guys, welcome back. So today I've got another Husky generator. And like the others I've worked on my channel, this one came in with a dirty carb, non-running. I did not film fixing or cleaning this carb, but I do have several videos on how to do that. So I'll link to that above right now, somewhere up here. Anyway, now that it's running, I can see we got another problem. And I'm sure you can guess maybe what that problem is. The power output is dirty. And you can see that when you plug in a light, that light pulsates. And that's not good. I mean, for the light, it's fine, but if you're plugging in sensitive electronics, potentially it could cause some damage. So I do want to go through this and see if I can clean the power up. And I'm going to try the easy things, really the only things I can do, which is swapping out the AVR or the brushes, or cleaning the slip rings on the rotor. But before I do that, I've gotten a lot of questions about how do you troubleshoot a generator that's not making no power, or dirty power, or the voltage or the hertz are off. So I'm going to cover that before digging into this, and I'm going to start with no power output. The easiest thing you can do if your generator is not making power is pull this end housing off. Take a look at both your rotor and your stator. So let's take that off and see what's going on. So before digging in here and running some tests, you want to look at it visually and see that there's nothing obvious wrong. And what you're looking for is really down on the stator. You want to look at the color of these wires. Make sure they're a nice copper color. Also, these ropes that tie the wires together should not be broken or burnt looking. And these look fine. Also, a little harder to show you, but in the middle is the rotor. You can kind of see it in there. And that spins with the engine. That also has copper wires. And again, you're just looking at the color, looking for any burnt wires. So these look good. If you saw that any of them looked burnt or those ropes were burnt, then you can stop right there. You know what the problem is. And I can actually show you on this one. This is a stator that I pulled out of a Briggs & Stratton. You can see all these ropes are broken. And that's because this overheated. And you can actually tell by looking at the wires, some of them are burnt. So this is an example of a bad stator. And when you see something like this, it's done. You can't really fix this. You could bring it somewhere and have it rewound, but that's going to cost quite a bit of money. And quite frankly, it's not worth it. You're better off just buying a new or a used generator to replace yours. So if the wires look good and you're not getting power, you might ask yourself, what could it be? And I guess before going into details on how to test, I'm just going to talk quickly about the theory on how this thing makes power. Right here is an example of a stator from a Briggs and the outlets. And quite literally, the outlets are connected via a wire to the stator. And this is what creates the power that goes to the outlets for your generator. And that's it. Now you might be wondering, how does that create power? And, by itself, it doesn't. It needs a magnet in here spinning to kind of induce that flow of electricity. And that is the job of the rotor. So I've got two rotors here. This one is actually from a Husky, like this generator. And this one is the rotor that goes with the Briggs stator that I just showed you. And these are both magnets. They're actually electromagnets, so they're not on right now, which is why this bolt doesn't stick. But you can see in the case of the Husky, it does have a little permanent magnet on each side. And that's important. We'll talk more about that later. But if your generator is not making power, either this rotor is not powering up because it's an electromagnet, it needs power, or you got a bad stator. And if you got a bad stator, what'll happen is if that rotor powers up, you'll hear the engine bog like it's under a heavy load, and that'll be followed by smoke from these wires. It's most likely the coating on the wires burning off. And I didn't mention this, but these wires are coated in like some sort of a resin. So they are insulated from each other. The current does not flow to neighboring wires, at least it's not supposed to. It's supposed to follow the circuit. So if that has failed, you could get a condition like this. The other reason is if you plug in too much of a load into these outlets, these will heat up to the point where they fail. And a lot of people don't realize this, but there's actually two legs in here, meaning there's two 120 volt circuits. So if you have a generator that's rated at say 5,000 watts, it's really only 2,500 watts on each leg. And if you try loading one circuit up with say 4,000 watts, you're way over what that leg is rated for. Even though the generator can handle 5,000, it's supposed to be balanced. And that can also lead to this. But assuming you don't get smoke and a heavy load, that's a sign that this is not powering up. So we'll take a look at that in a minute. But there's a few things to note here is that these do need residual magnetism to power up. Actually, this one does. This one has a permanent magnet. And a lot of generators, actually most that I've worked on, actually all that I've worked on that have AVRs, have a permanent magnet. So residual magnetism should not be a problem. But on one like this, which came from a Briggs & Stratton, there is no magnet. So if you lose the residual magnetism, the system can't start itself. So we'll cover that a little bit later on how to fix that. But getting ahead of myself here, you know, we've determined visually that this is good. The next test is to actually get a meter and check the ohms. So let me get you set up and we'll do some quick tests. I've got it set up here in ohms. And this generator, I know that each of these black wires is one of the 120 volt legs, is two legs. And they're common together here with the neutral. So first thing you want to do is just check the resistance of your meter by connecting the leads together. And this meter I think is around 0.1. And that's the number you want to subtract from whatever reading you get up here. And on this generator, I know a healthy reading is usually around 0.3. Yours might be different. And if you don't know what it should be, just compare the two. So you can see this winding is around 0.4. If you subtract the 0.1, we're at 0.3. So that's good. And then the other winding, yeah, it's the same. So if you don't know what the reading value should be, just compare the two. You know, these with this. And they should be about the same. If they're not, you might have a problem. And even if you don't know what the readings are, they shouldn't really be much more than 1 ohm. But I've seen some generators that are maybe up to 2 ohms and down to like 0.1. If it's open lead, it'll say OL. Or if the resistance is higher than, say, 2 ohms, you got a problem somewhere in your stator. And you know what the problem is. But this one tested well. The next thing to do is to test the rotor. Yeah, and to test the rotor, you actually need to pull the brushes off and test directly on the slip rings. Now I've already done that and I get 55 ohms. So I know this rotor is good. Generally 50 to 60 ohms is what I see, but you know, yours will be different. It could be anywhere between say 7 ohms and maybe 100. You know, if it's lower or higher, again, rotor might be suspect. So I'm going to test the resistance on these rotors just to give you examples of readings that you could see. Generally between 7 ohms and 100, depending upon the generator you're testing. This rotor is from a Briggs & Stratton. You can see it's smaller, has less wire, and it seems thicker. So I'm expecting the ohms to be Probably around like 20 or 30. Yeah, so like 20, 24 about. And this one has a lot more wire and it's thinner, so the resistance should be higher. Yeah, 52 ohms. So those are good. All right, so we visually inspected everything. It looks good. The ohms tests are good. What's left? Well, the big thing is what powers up these rotors. And the answer is a little different depending upon what type of setup you have. In the case of one with an AVR, the rotors usually have permanent magnets. And those magnets, well, you won't lose residual magnetism because you have permanent magnets. If you have a generator that doesn't have an AVR, like that guy, it just uses a bridge rectifier. And these don't, for whatever reason, the ones I've looked at anyway, don't have permanent magnets. So you could get into a scenario where residual magnetism is lost and this thing will not power up because there's absolutely no magnetism. So we'll cover that in a minute, but there is another reason why this isn't powering up, and that's that both of these, there's two prongs here, and these are inputs. So both of these have usually a separate winding on the generator to send power just to the AVR or the bridge rectifier. And you can also do an ohms test on that to see if it's good. And in this case, it's the blue wires that receive that signal, which are the two on this side. And to do that test, you just unplug your AVR from the stator and then connect your meter to those wires. And the resistance is a little higher. It should be around 1 ohm, give or take half an ohm. And again, that varies from generator to generator. I'm going to cheat a little bit. You can actually maybe test it from the back side without unplugging it. And again, to get the most accurate readings, you should just unplug it. You can see we're getting a reading of 1.9, 2.0. So that is a little high. I've actually never tested the resistance of, this winding before on this generator. The last one I tested was on a rigid, I think it was, and that tested at 1.6. So this is probably fine. Again, if it was way higher or 0 or open lead, that would be a problem. But this is probably good. The other issue is too, and maybe I'll cover this more later, these other two wires are sense wires, and it basically sends the voltage to the AVR, and that's how it determines if you need more or less voltage to get the 120 volts. And let's say you power this thing up and it's generating 170 volts. Well, this thing is running at full power, and that's usually a sign that it's not receiving the signal, the sense signal from these two wires, or the AVR is bad. So you still have no power. We've tested the ohms. They're good. We've visually inspected it. Everything's good. We've also checked the wires that are supplying power to the AVR, and they seem to be good as well with the resistance. So now we're really left with the AVR, or in the case of a generator that doesn't have an AVR, it could just be the bridge rectifier supplying the power to the brushes, or loss of residual magnetism. Either way, the way to fix or at least test those problems is to supply power with battery to the brushes. So in order to do that, you just need a 12-volt battery. It can be a bigger battery, but I like to use a small one just in case. And then you got to remove these wires from the brush assembly. Red's on the left, black's on the right. And if you got something like this, these clips makes it a lot easier. You don't want to apply voltage when it's not running. And you just want to get one clip on each brush. Positive on the left, negative on the right. So now that's hooked up. And at this point, you would start your generator and plug something in to measure the voltage. It could be a light or a multimeter. And I also added a fuse here, a 10 amp fuse in case something goes wrong. But once this thing is running, you can just apply 12 volts. Not for too long, maybe 5 or 10 seconds, long enough to see what the voltage output is. And with this setup, it's not going to produce 120 volts. Most likely it'll be less, probably between 50 volts and 100. It really depends on your generator setup, but what you want to see is that it's producing something around there. And if it is, then you know that this rotor powered up, power's coming out to your outlets from your stator. And now you just got to figure out, you've pretty much ruled out everything. Most likely, if you're getting good power now, it's your AVR, or you lost your residual magnetism. And by doing this, assuming you hooked up the polarity right, you just restored your residual magnetism. So you might next shut down the generator, disconnect these wires, reconnect these, and start it up again and see if the generator can start its own power cycle now that you've essentially flashed it. If it's still not making power, then it has to be the AVR. Replace that, and most likely you'll be fine. Now, if your voltage is too high or too low, or the hertz are too high or too low, that can be adjusted. The hertz, in the case of a generator like this, are tied to engine speed. So if you're running at, say, 55 hertz, that's just a sign that the engine speed's too slow. And a lot of these have adjustments. In this case, there's an adjustment right here for the throttle. And on others, like this Briggs, you can't actually see it, but under this cover, there's a tab with a spring that you can bend, and that'll change the engine speed. If your voltage is off, sometimes it is adjustable. If you have an AVR, like this one, it has a potentiometer. And if you turn it counterclockwise, the voltage will go down. Clockwise, it'll go up. And the voltage is completely independent of engine speed with these, but hertz are not. Hertz are not controlled by the AVR, purely the engine speed. And on a setup like this, there is no voltage regulation. The voltage is directly proportional to the engine speed. So if your voltage is 140 volts, your engine's too fast. And if you were to check the hertz, you'd probably see that as well. The hertz would probably be around 65 hertz. And same thing, low voltage, low engine speed, low hertz. Make the same adjustments on the engine to adjust that engine speed to something more desirable. Generally with no load, a setup like this, you'd want to run it at 125 volts with no load. And yeah, that pretty much covers it as far as the troubleshooting. Doing these different things will allow you to kind of pinpoint where your problem is and kind of dictate where to go and what to do. So in this case, this generator makes power. Visually, everything looks good. Ohms-wise, everything looks good. But because the power is dirty, potentially there could be something wrong inside the AVR. Maybe the brushes are damaged or dirty, or the slip rings have some sort of a defect or just too dirty. So those are the easy things I can do to this generator. See if that makes a difference. If not, maybe we'll dig a little bit deeper, but Let me first bring this thing outside, start it up, and kind of show you what it's doing. All right, so I think you could see what it was doing there. It was fluctuating under no load and pretty solid under a 1500 watt load, even a 1300 watt load. What I want to do here, the voltage coming out of here actually is a little low. It's like around 116. This AVR is adjustable, so I do want to adjust it a little bit and see if that makes a difference before pulling this. And you want to be careful too with this. Even with this, I mean, you never want to touch this when it's running. There's moving parts, high voltage. Even when it's off, this capacitor will give you quite a zap. Although it is potted, so it should be fairly safe, but just use common sense. In order to increase the voltage, this potentiometer needs to be turned clockwise. So I'm going to turn it 1 or 2 turns, start it back up, and see what the voltage is and see if it makes any difference to that pulsating. All right, so I did 1 full turn there. It was at 116 before, so let's see what it's at now. All right, so 1 full turn did about 20 volts, which was kind of surprising. So it was at 116 before, so I probably only wanted to do about a quarter of a turn. So I'm going to back that off. Hopefully. Half turn, and then about a quarter. See what that is. You don't want it to be above really 125, 127 volts. Ideally, it would be 120. Alright, so the voltage is still a little high, but as you saw, the power was still fluctuating, and so adjusting the voltage really has no impact on what's going on here. So the next step is I'm just going to replace that AVR and see if that makes any difference. Okay, so I was tempted to use the generic new one, but you can see the heat sinking here is pretty sad. The old one had a much beefier heat sink, and this one has a really nice heat sink. So I'm going to try this one first. If I remember right, it produces too much power, and there is no potentiometer to adjust it. But I'll give it a quick try and see what we get. All right, so the brush you do want to pay attention to. It is polarity sensitive. In this case, the positive is on the left, which is pretty typical. Okay, so put the new used AVR on, in my case. Black wire on the right, and the red goes on the left. So, like I said, I think this AVR is broken and putting out too much power, so if that's the case, I won't run it for very long. Okay, so as you saw, switching out the AVR did not fix the problem. So I put the original AVR back on. Next, I am gonna pull the brushes and inspect them, see if there's anything obvious wrong. Okay, so overall, these brushes don't look bad. There potentially might be a little bit of unusual wear in this corner, so I'm not sure what that is, but you can kind of see it right there. So that could be our problem. The other thing you want to look for is to check the springs. Make sure there's enough spring tension. And yeah, these feel pretty good. So other than that, I don't see anything else wrong with these brushes. I'm going to do a quick ohms test through them. I don't know what the reading's supposed to be on these, but I have tested other brushes and they're pretty low. Like I think it's around 0.2, 0.3 ohms. Yeah, that one's good. Yeah, so I don't know what the acceptable range is here. This one isn't too bad, but it seems like there's a lot of areas on this surface that aren't great. And this is the one that looks either chipped or burned. So that's definitely suspect. So I will put on a new set of brushes and try it again. These are the new brushes. And I'm going to take an ohms reading through the brushes. Now this rotor should be in the 50 to 60 ohm range, and you can see here through the brushes I'm getting 63. And I didn't show it, but I did try doing an ohms test through the old brushes, and I was getting erratic readings. I could not get a steady ohms reading, so this could be a good sign. Not sure. All right, so the new brushes are on, the wires are on. Just gonna do a quick test, see if it makes any difference. So unfortunately, changing the brushes did not fix my problem. So we tried the new AVR, tried the new brushes. I did kind of wipe down the slip rings just with a dry rag. And, at this point, I'm kind of out of options. I think it's something to do with the windings, either in the stator or the rotor. But regardless, I kind of gave you guys a overview of the 5 components, at least in this case, that make power. And if your generator's not making power or making low or high power, or dirty power, it gives you a few options to try. Anyway, hope this video helps someone. Thanks for watching.